Great. So hello everyone, I hope you are doing well. And today we are going to talk about sedimentology, which is one of the most important part of the geology, because these things are not directly related to geophysics. But in order to find oil and gas, of course, you are directly engaged and involved in some processes. It keeps into sedimentology too, but it's not directly related to geophysics because while learning sedimentology, your main scope is to understand the sediment itself, the sedimentary rock, and then the environment, the depositional environment. And that's the most important thing. And in general, sedimentology is learned in order to reconstruct the past environment, which I claimed as depositional environment. In science, its name is depositional environment. So let's skip to the second page. Here we see the table of contents. Today we are going to talk about introduction to sedimentology. Here we are going to talk about what sediments and sedimentology actually is. Then we will talk about types of sedimentary rocks. Then we will talk about sedimentary cycle, which is one of the most important parts of this presentation, because in order to understand the sedimentology, you should know the processes that are involved in sedimentary cycle. And actually in sedimentary cycle, we mean that the processes that makes the sedimentary rock at last. Then fossils in sedimentary rocks. We will see some types of rocks that keeps in some fossils and some plant traces. And the last we are going to talk about is applications of sedimentology, why we learn sedimentology, and how is it applied in science.
Sorry, we don't see the next slide.
Do you see now?
Yeah.
Okay, great. Then I will go to the second slide, introduction to sedimentology. So firstly, let's talk about what's sedimentology. Basically, sedimentology is the study of sediments. You have some sediments and you learn it, and there are some processes which are involved in order to get the sedimentary rocks, and these all are called sedimentology. So I would like to clarify some point. Let's say that you have a what quartz mineral somewhere, but it's not as rock. It's just something. It's not something solid. If it's not something solid, you can say that that's a sedimentary rock, because in order it to be rock, it should be something solid, rough, and if it's not, then it's just sediment, not a sedimentary rock. In order a rock to be a rock, it should go from diagenesis part, because in diagenesis part there happen some compaction and there will be change in pressure and temperature, and in this way you will get the sedimentary rock. We are going to talk about it much broadly in the next slides, but I would like to clarify what's the difference between sediment and sedimentary rock. And then, as I mentioned, in sedimentology, there are some processes such as formation, transportation, and deposition of sediments, and at last transformation of these sediments into sedimentary rock, which is diagenesis part. In science, we call this part as diagenesis. And the formation that is indicated in this text is actually weathering and erosion, and we will also see that. But let's talk about what's sedimentary cycle. Sedimentary cycle, as it's written here, it refers to continuous process by which sedimentary rocks are formed. So if you have a sedimentary cycle, it claims that for 100%, you will start with some sedimentary particles, sedimentary clasts mean particle, and with sedimentary clasts, and at last you will get sedimentary rocks. That's the main idea here. And in order to get the rock, you should undergo diagenesis. Okay, let's see some sedimentary rocks. In science, basically, there are sedimentary rocks in three types, but if we go more detailed, there will be four types of sedimentary rocks, and I'm going to talk about it in the next slide. But for now, let's talk about this one. These are the basic ones: classic sedimentary rock, chemical sedimentary rocks, and organic sedimentary rocks. Classic sedimentary rocks are only made of from particles and clasts, which are not, let's say that you have an acid, then you put that acid on the rock, and if there is no any reaction, in that case, we can claim that that's classic sedimentary rocks. And in order to understand this type of rocks, you can use just only your eyes. And if you see some small particles, even if you just touch it and then look at your finger, if there are some particles, it means that these are classic sedimentary rocks. The basic and well-known sedimentary rocks are sandstone, conglomerate, and breccia. I'm going to talk about conglomerate and breccia in the next slides, because these are important to understand why one of them called conglomerate and why one of them called breccia. And the chemical sedimentary rocks are the well-known examples are limestone and dolostone. Why these are chemical sedimentary rocks? Because if you take the acid, for example, H chlorine, then you will see, if you put that acid on limestone, you will see some gas bubbles are happening there, like you get some gas bubbles, and it means that there is a reaction. And if there is a reaction, it is chemical sedimentary rocks. And the third one is organic sedimentary rocks, which are coal and organic rich shale. These are just organic sedimentary rocks because it not only keeps inside the particles, but also some organic materials, such as in order to get the coal, you should bury it and below even 1 kilometer depth and even maybe more. And there are some, processes happening because beneath, let's say, sand, actually soil, there are lots of plants and lots of fossils. So it somehow affects it in order to be organic sedimentary rocks. And yeah, that was what I was talking about in a more detailed way. Sedimentary rocks are divided into 4 places, such as detrital terrigenous rocks, biochemical rocks, chemical rocks, and residual rocks. So what's the difference? Detrital terrigenous rocks are the ones whose particles and clasts are seen obviously with your eyes, and which are let's say formed in the land, not in the sea. These types of rocks are formed in the land, such as in mountains, like on the mountains, or just basically on the surface. But biochemical rocks are containing some fossils in it. If you see a rock that contains fossils, you see that you can claim that that's a biochemical rock. And the third one is chemical rocks. In order to understand if it's a chemical rock, you should have big and shiny crystals, and then you can claim it's chemical rocks. And also, to check that, again, you can use the acid that I was talking about. You put some acid on it, and if it gives some gas bubbles to you, it means that's chemical rock. Then the last one is residual rocks. In residual rocks, there are a high percentage of iron and aluminum elements. And because aluminum and iron is pretty heavy elements, that's why residual rocks are heavy in general. And in residual rocks, you can't see any stratas. Like for detrital terrigenous rocks, that's pretty normal. You can see some different stratas. But for residual rocks, that's impossible. And the residual rocks are generally can be called mother rocks, because in geology there is this thing. Always you start with a mother rock. A mother rock is the rock that is very heavy and very gigantic, but then some processes happen on it, such as weathering, erosion, and after these processes, some elements are going away. Let's say potassium, let's say sodium. These are not resistant elements, so that's why they are just leaving the mother rock. And then the mother rock just only contains iron and aluminum. So that is what we call residual rock. After some point, because it lost some of its initial elements, it's then only contain iron and aluminum, and then we can give it the name of not a mother rock, but a residual rock. So next slide. In next slide, yeah, we can talk about the sedimentary cycle finally, which is very important. Try to understand that part. And if you have any question, please don't hesitate to ask. So as I said, we always start with mother rock, as it's indicated here. And then some processes happening, such as weathering and erosion. Erosion is actually written here, but in general, in geology, we talk about weathering and erosion at the same time, not erosion and transportation, but not a problem. So by weathering, by the way, weathering is also divided in two parts, mechanical and chemical. Chemical means that there are some chemical processes that is happening, for example, oxidizing. And by this way, mother rock lost its initial elements, such as I said, potassium, sodium, such as these ones. And mechanical weathering is only just, let's say, it's raining and like because the raindrops affect and touch to the surface of mother rock, there are some weathering happens, and by weathering you will get some particles and ions. After getting the particles and ions, the erosion and transportation happen. Like what transportation mean here, that you get some small particles. By the way, here ions mean that, as I said, that in weathering part, you will get some elements going away, such as sodium and potassium, and these are the ions we are calling. Okay, for particles and ions, there is transportation. So transportation means that there are some transporting agents, such as ice, gravity, water, wind, and these are taking these particles much more away from the initial location, from mother rock, and it deposits these particles and ions somewhere else. So that is why the third part is deposition, called deposition. Like by transportation, you will get these particles and you will deposit it somewhere. Like you will accumulate these particles, and after some point there will be lots of particles that is okay for creating rock, basically. Okay, after some deposition you will get sediment. Lots of particles should be there in order to get the sediment, but again, it's not a sedimentary rock because it didn't undergo the diagenesis stage. In order to be a sedimentary rock, it should go a diagenesis process. So after, let's say we have currently sediment, then it goes a diagenesis process. What diagenesis process is, there is completely difference between temperature and pressure. Let's say you deposit the sediment for the beginning, in the beginning, with 1 meter depth, but as there is a deposition and accumulation of particles, you will bury these sediments below 500 meters or kilometers maybe, but I don't believe it can be kilometers. It's too much. It's probably 100 meters, 1 kilometers only, and sometimes 3 to 3, let's say. No, actually, it can be up to 5 kilometers, I believe. Then, because there is a difference between temperature and pressure when you are above and below, as you know, the compaction process happens. Compaction means that the pressure increases and it kind of tightens the sediment, and also temperature increases. So at last, there is a creation of sedimentary rock, which is solid, which is rough in that case. So after getting the sedimentary rock, because the sediments were burying up to 5 kilometer depths, you get the rock up to 5 kilometer depths. Let's say you get that rock in 5 kilometer depths, and then you need to see it in the outcrop. And with time, as tectonic processes happening, you will see the exhumation. Exhumation means that sedimentary rock, which is formed below the surface, comes up, and now you can see it with your own eyes. Okay, is that part clear? So the rocks that you see with your eyes currently is the rocks actually probably formed below the earth, below the surface at some point. But during the exhumation part, they all came up. So that's the exhumation. Do you have any questions related to this part?
No, everything is clear.
All right, great. Yeah, that's the video. I would like to take your time and watch it about weathering. So how weathering happens is that now you see that it's raining and the raindrops touch the surface of the rock. And now you can see some cracks because it's happening all the time. And after some point, it doesn't get tightened, and that's why there are some cracks. Then it's snowing, and the snow particles and snow actually is located in that cracks. And after some time, when sun comes, there will be some plants even growing, and these are all causing cracks. And you can see that there are some, fragments of those rocks here. These are small fragments of them. So once these ones were here, like at this point, but because of the fractures, because of the weathering, now they are, cracked and dropped to that place. So basically weathering is that idea. It's pretty simple, I believe. And there are lots of animation you can find on YouTube or other social media. I actually use YouTube, and I will send you the link of this video so you can watch it by yourself. Let's talk about transportation and deposition and diagenesis a little briefly, because we talked about them in the sedimentary cycle. So transportation is just taking away the particles from the mother rock to the new location, completely different locations. And transporting agents are wind, water, ice, and gravity. And the most strong one is ice. Um, the strongest transporting agent is ice, basically. I would say that gravity is not that strong, because gravity only affects for the mountains generally, or the hills, that after some point you see that some part of the mountain or hill is just going away because of the gravity, just gravity. There was no effect of wind, water, and ice. And by the way, by transporting agent water, most of the time you get shiny rocks, because water somehow affects it, and at last you get the shiny rocks, shiny types of rocks. Deposition, we talked about deposition, like as you deposit the sediments, as the sediments are accumulated, there will be formation of sedimentary deposits. And the diagenesis is the burying the layers, and after undergoing diagenesis process, you will get some changes in physical and chemical properties, and at last you will get solid rocks. So this is the types of fossils. I claimed that we will see some fossils in sedimentary rocks. Basically, that's the rock. You see, normal rock, we can't claim anything on it, but you can see some fossils here. Then you can claim that that's a biochemical rock because it contains some fossils. The same thing is applicable for this one too. Basically, that's again a rock, but you see that there are some fossils on it, so it is biochemical rock. Again, the same thing for this one, because you see that some shells here, and it shows that that was in underwater. So it is a biochemical rock because it contains some fossils in it. And this is not directly a fossil because it is a plant. You see that it kind of looks like a leaf. And you can here, by looking at this, you can claim that it is a plant traces in sedimentary rocks. By the way, because it was plant, we call it plant traces. But if it was a trace of any animal, any kind of animal, then we could call it bioturbation. Then this one, application of sedimentology, why we learn it. We learn sedimentology because it helps us in petroleum exploration and production. Understanding sedimentology is really important because in order to get the petroleum, actually, you should know some sedimentary processes. You should be sure that the rock is mature enough that it can contain some oil and gas. And also the processes involved are important because you should have some rocks, and if diagenesis is not done, then you can't, it's not even rock to contain petroleum in that case. So understanding sedimentary processes in petroleum exploration is really important. And then groundwater resources, which is directly similar to each other. Like by understanding sedimentology, you can understand the aquifers and groundwater resources, because again, if you have a sedimentary rock, then you have porosity and permeability. Without having sedimentary rock, you can't have them. And in that case, it's meaningless to make an exploration part on groundwater resources on that specific location. Then mineral resources comes, and that's very similar to groundwater resources again. You always have to learn sedimentology, understand sedimentology for the same reason, because if you, in sedimentology, you work on sand particles, you work on gravel and limestone, and by having these types of rock, you can assess any mineral resources. So that's why it's important to understand mineral resources. And even in construction, in let's say some apartments are built, and the things we need in construction are always come from sedimentary minerals such as silicium O2. You should get sand, you should get gravel to get the cement, which is used in construction. So that's why mineral resources is also in the scope of understanding sedimentology. Yeah, after this part, we will work on some examples until defining the deposition environment, because at first I claimed that we learn sedimentology in order to get the sediment depositional environment at last. So I will show you some types of rocks here, and we will find its name, its mother rock, the type of weathering, the transportation agent and distance, and at last the positional environment. So let's start with the first one. Yeah, as I said that I will come back to conglomerate. This rock is conglomerate, as you're seeing. You know why? Because that's the only rock, but you see that there are some particles which is very big and which is not triangular actually, which is rounded. And if you have a rounded big particles on a rock, it means that is a conglomerate. And in order to find its mother rock, it can be any type of rock which contains silicium O2, basically, because it looks like a sandstone. If it's a conglomerate, it can't be any biochemical rock, it can't be any chemical rock, it can't be any residual rock. It only can be detrital heterogeneous rock. And in that case, its mother rock can be any type of rock with silicium O2, and it can also be granite, which is the most common one. Most common one is granite. It can be granite, and it can be also sandstone. So when claiming the mother rock, you can talk about them. Then weathering comes. For this one, I would say that weathering is mechanical, because there are no chemical processes happen. Obviously, there is not a color change. There is only some, compaction of big particles in one type of sedimentary rocks. So that's why it's mechanical weathering. And in order to talk about this transportation, one can say that it's transported by water, because it can't be transported by wind. If it's conglomerate, it means that if the particles are rounded, it means that it is transport for over 1,000 kilometers distance. Like it transported way away from the mother rock. So that's why in order it to go that further, the water agent is the most common one because it can't be wind. Wind is not that effective to take a particle for over 1,000 kilometers long. So that's why probably it's water, and the transportation distance is 1,000 kilometer long. And at last, if, as we said, that it is transported by water, it means that the possible deposition environment is fluvial. I am sure that you still don't know about deposition environments because it is another part of geology. It's another disciplinary, but I should claim it here. It's fluvial. So basically what fluvial deposition environment is that if you see that a river is flowing, then it's a fluvial system. Like basically I can explain it in that way. So let's see the answers. I actually indicated them here. So it was a number one. It was conglomerate. It is sandstone. It can be sandstone, granite, and it can be any type of rock contains silicium O2. The weathering is mechanical. The transportation is water, and distance is 1,000 kilometers, and at last, deposition environment is fluvial. Then this rock, again, anyone can indicate which type of rock is that, just the name for that rock. Okay, then let me answer quickly. This is biochemical rock, guys, as I told previously, because it contains some fossils. If it contains any fossils, it is biochemical rock directly. And since it is biochemical rock, it is formed in under the sea, under the water. You can't claim it's mother rock. So that's why if it's asked it's mother rock, you can't say anything. So that's why you should skip that point. And then because it's biochemical rock, the weathering process involved here is chemical. It is chemical weathering directly. And if it is a biochemical rock, it means it contains some fossils. It happens under the sea, under the water, and then its transporting agent is for 100% water. But you can't say anything about its distance, transported distance, because it only contains some fossils. We can't claim anything on its distance. And then its deposition environment is under the water. It can be marine environment, basically marine environment. It can be shallow marine environment, deep marine environment, but for 100% it's a marine environment. Marine environment means that it is some environment with lots of water above. It can be basically ocean. So the answers are indicated here, the responses. It is by chemical rock. It is weathering, chemical weathering is actually showed itself here. The media is basically water. Distance can't be determined. And marine environment, it's the position environment is. And the last one, that is actually Brescia. I would like to ask the question to you, but let me answer. Basically, that is Brescia. Why Brescia? Because you see that there are some particles which are not circular, which are not rounded. This is basically looks like triangular. So that is why we call them Brescia. And if it's a Brescia, it means that the transportation distance is not long as in conglomerate, because as the particle gets rounded, it means that it is transported for lots of distances. But if it's just a triangular shape, it means that it is not, transported for lots of like lengths, because it starts with, let's say, above the mountain, and it goes only 250 up to 500 kilometers long, because it's not rounded still. So that's basically what breccia is. That's the difference between conglomerate and breccia. And again, there is no other difference for breccia and for conglomerate. That's not that complicated, because for its mother rock, again, we will say that it can be sandstone, granite, and any type of rock contains silicium O2. Its weathering is mechanical once again, because there are no chemical processes involved here. The transportation it can be transported by both water and wind. Because it's not that rounded, it means that it can be transported by wind for up to 100 kilometers. So wind also should be indicated in that type of rock. And the transporting distance can be up to 500 kilometers, but it's too much actually. It can be like between 300 kilometers, something like that. And it's the positional environment, because it is the transporting agent is both can be water and wind, then its deposition environment can be fluvial, because transporting agent was water, but also it can be alluvial. Alluvial is just only you have like mountains shape, and because of the gravity, you just, some part of the mountains just goes away. It drops all the particles on it, and that's the alluvial deposition environment. So there is not a huge transportation long. Yeah, it just starts at some point and finish in up to 50 kilometers, something like this. It can't go more than this. So that's alluvial, and actually alluvial ones have a shape of bells, because there are two mountains, like these two mountains close to each other, and then in the middle there is a alluvial thing, and it transports some particles which is not go further away, and it can be breccia because it's not transported much away from the initial location. So for this one, let's see the results. Again, it can be sandstone, granite, and silicium O2, any rock that contains silicium O2. Weathering is mechanical, media is water and wind. Because media is water and wind, it is indicated that it can be both fluvial and alluvial, and the distance is up to 300 kilometers in order it to be a breccia. Because it's not rounded, it's only triangular, it means that it's not transported for lots of distance. Yeah, that was all for today, the sedimentology. I tried to go very basic. I tried to give you a brief information about what sedimentology is, so that in the next year, if you are a second year student, the next year when you are learning something about sedimentology, I believe that for 100%, it will be much more easier to you than it was for us, because the lots of basic informations are given in this slide. So I highly recommend you to revise it before starting sedimentology classes of yours, so you will understand everything easily and completely. So guys, do you have any questions regarding to the presentation?
No, thank you for the lesson.
My pleasure.
No, thank you.
Thank you. Thank you for participating. And at this point in time, it's worth mentioning that that was the last class just delivered by me. For this course, I had 4 sessions to talk about. So thank you all for coming to the sessions when it was offline, and thank you for participating when it was online. So goodbye, and see you in the next sessions of this course.
Thank you so much.
Goodbye.
Thank you.
Goodbye.
Goodbye.